Hello everyone, this is my first lesson on the topic vectors, and as you see here in this video, this topic is basically a very important topic in IB Diploma Mathematics, higher level as well as the standard level, but it is not limited to just IB. It can be used for the further mathematics or just mathematics for GCSEs, IGCSEs, and even it can help for the students who are doing their A levels or AS levels in mathematics. So in this video I'm gonna focus mostly on the two things, and the first of them is deriving the equation of a line in 3D. So we are talking about the vectors. Vectors are basically, you can consider it like a quantity which is having a magnitude like the length as well as a direction. So here if you see these lines are showing the vectors because they are showing a certain length as well as they are showing a direction. So now we have already learned about the lines, right? We use the equation like y is equal to mx plus c, that is in the coordinate form, coordinate geometry. Here we will be talking about the vector equation of the lines, and it will look like something this way. R is equal to a plus lambda b. Here these arrows are representing that these quantities are the vector quantities. I will be trying my best to include the basics as well. So here first is that we will be deriving the equation of line in 3D, and second is what is the vector form of a line and how to write the equation of a line in the parametric form. So I will explain what is the meaning of the parameter. So the first thing is deriving the equation. Now a very simple stuff that we have to describe the equation of a line. Now let's say I am drawing a line and I will be given it as direction also. So for example, this is a line and there will be two pieces of information will be given to me for this line, and let's say here is the origin and here is a certain point on the line and I consider it like A. Now this A to O, when I join this, it will be giving me a position vector A. So I can give a direction like OA. I am giving the position of this point A which is on the line with respect to the origin. So this is known as a position vector. Now the second point, a random point I am taking on the line is like R. It is a general point. Then the direction of this line, there is a vector which is in the direction parallel to this line, and that vector is B. Now we know if the two lines are parallel, okay, they have the slopes and their slopes are equal, but in the vector form, if the two vectors are parallel, then one vector can be written as a scalar multiple of the other. Here this lambda is like a scalar value. So now let's say this R is a general point on this line. Just remember this thing. So if I join this R to O, because I'm talking about a position vector, so if I have to find out this OR, this is a vector OR, using the triangle law, I can say this is OA. I will be going from O to A, and then I will be going from A to R. This is a triangle law of vector addition. So OR, I can consider that the coordinates of R are like, let's say, x comma y. So I can consider it like this is a vector form, so I can write it xy. If I am considering it in 2D, it will be xy, but if I am considering it in 3D, so I can write x, y and z as well. This is equal to OA. Now A is a point which is given on this line. It will be given, this piece of information will be given in the question. So I can consider it like, let's say if it's a 2D, so it will be like A and this A1 and A2, you can consider like that. And if it is in 3D, you can take it like A1, A2 and A3. There will be X, Y and Z component, and then plus AR. Now we know the direction is given for this line, that is parallel to the vector B. So because AR is a vector which is parallel to vector B, so I can write it like lambda times B. And if I am taking B in a 2D, 2 dimensions, so I can write it like lambda. Instead of this, I can write it lambda B1 and B2. Similarly, if it is in 3D, I can write it lambda B1, B2 and B3. So this is the vector equation of line in 3D. This is the vector equation of line in 2D. Just two pieces of information we have to remember, and those pieces of information is that there is a point which is a given point, so it will have coordinate like AB. There is a general point and the directions are given, the parallel vector. Now from here we can derive the another equation, and that is known as the parametric equation of the line in 3D or in 2D. So for that, what we need to do, we will continue with the same process. We will be using this vector equation. So here we have given, if I am talking in this equation of line in 3D, so I got xyz, which is a general point, that is equal to a1, a2, a3. This is a point which is given on the line, plus a scalar value which is lambda, u, p, anything you can say, but you have to mention that this is a scalar value. And then we have this vector, parallel vector, which is b1, b2 and b3 components. Now if I say again x, y, z, because it is a vector, and on the right side I can add up these vectors, so it will be a1 plus lambda times b1, a2 plus lambda times b2, then a3 plus lambda times b3. Now these are the two vectors given, and if you have the two vectors with an equal to sign in the middle, so we can equate the components. So I can say x is equal to a1 plus lambda times b1. Here this lambda is a scalar value, this is a parameter, and that is why it is known as the parametric equation, because each x, y and z component, or even if it is 2D, so x and y component, they are expressed in the form of a parameter. Y is equal to a2 plus lambda b2, and last z is equal to a3 plus lambda b3. Okay, so we have covered two things in this lesson. First is the vector form of the equation, and the second is the parametric form of the equation. This is the parametric form. I hope this topic is clear to all of you. Thank you.